All right, so to use the Additel 227 to control and test the valve is pretty easy. What we need is actually one Additel 227 HART communication version. Yeah, we do need a HART communication, and we need a 4 test leads, 2, 3, 4, and also 2 alligator clips. So the first thing is a connection diagram. So we go to the 227, go to the interface, and select the HART communication on the upper window, HART communication. And then we select this one. We have 3 options. HART communication with the internal power and the internal resistance. HART communication with the external power and external resistance. And also the valve test. Okay, so this is a diagram. So that means we need to use the 4 ports, 1, 2, 3, and 4. Okay, so we just need to follow the instruction. So right here, this is the first one, and short circuit to this one. Okay, and then find a longer test lead to connect this one. Okay, this one, and the alligator clip. All right. So for the black, this one and this one. Okay, and then use a longer clip, test lead to connect this one, and also the alligator clip. So for the 2 alligator clips, we need to connect to the valve. Negative and positive. So right now you're hearing something is venting out from the system. Okay, because right now the controller is on. This is the vent port, if you can remember that. This one, vent port, is actually this one. Okay. All right, so for the interface, that'll be something like this. Okay. The upper part, that'll be the measurement or the reading. We have a different variable. So we have a PV that indicate the milliamp. We have a percent of range, which indicate the true movement of the valve. And also we have SV. SV is actually the calculated result, return value by the controller. So this is actually the result in theory. So this is not the actual result. Indicate the movement. Okay. All right. So if you want to control the valve, we just need to change the output milliamp right here. For example, so right now it's 3.8 milliamp. So watch out this the movement part. Okay. And to change the output, we have a lot of different methods. We have a ramp, auto step, manual step, and jog. So ramp, that will be range 4 to 20 milliamp, like racing, like ascending process time, that will be 5 seconds. Descending program, that will be 5 seconds. Waiting at the 0% position, and waiting time at the full open position, and repeat, that'll be something like this. Okay, the other one, that'll be auto step. So round trip, cycle, that'll be 1, cycle interval, that'll be 1 second. Dwell time, 2 seconds. Step mode, we can select a point, percent, value, or the custom. So for example, custom, we can set the set point. Okay. For example, we want to do the first point, that would be 4 milliamp, 5 milliamp, 7.2, 13.6, or 20. We can delete some, add more. For example, I want to do downgrade, like 16 and 4. So now we have a 4, 13.6, 20, 16, and 4. So then, okay. All right, so this is auto set. We have the menu step. So menu step, we can change like 25% of the entire range. So for now, the entire range is 3.8 to 21, not the traditional 4 to 20. Why? Because normally 4 milliamp means 0% open, which means fully closed. And 20 milliamp, that means fully open. But sometimes the customer may want to make sure that the valve is absolutely closed or absolutely open. So we need to get something extra. So 3.8, that means we get something like more than 100% close, more than fully closed, or we can say the over close. And 21, that means more than fully open, something like that. So yeah, so this is the step. And for the step, the volume of the step, we can change 25%, 100%, a certain value, or custom, maybe 30%. So right now we can change 30% to downward or 30% to upward. Okay. The percent means the entire range for now is a 3.6, 3.8 to 21. Okay. Yeah, so this is the basic interface. We do have, if customer want to use a 227 to calibrate the valve, we do have a task. Create a new task, valve positioner, and we create a task. Name, serial number, model, input, that will be 4 to 20 milliamp. Okay, output, that will be, yeah, 4 to 20 milliamp. Because we don't, because we cannot, use the movement in percentage as output. So we have to use a 4 to 20 milliamp right here. Okay. The accuracy, that will be 0.1. Owner, location, node. Set point, that will be 4, 8, 12, 16, and 20. And then cycle, that will be 1. Stroke, that will be round trip. The wheel time, let's say 2 seconds. Okay. Okay, we can start. Automatic. Okay, I think the reason why there's a lot of errors is because this controller doesn't output any signal right here. Let me check if I can. Oh, sorry. I should select the field bus. PV. Yeah, HART PV. Sorry. And then save. And then we run again. Automatic. Yeah, right now it gives the correct output signal. Okay. Or we can do something different, like we use the output and change the output as a percent of range to indicate the true movement of the valve. So let's say automatic. So 4 milliamps should be 0, and 8 milliamps should be 25 or something. 12, that would be 50. And then 16 should be 75, and 20, that would be 100. Yeah, so this is the result. Okay, and then we can save it. Okay. If the customer really want to do the adjustment, just like you can see on the test, we have a lot of points that is out of tolerance. If we want to do the adjustment, we need to go to HART communicator. So this is the reason why we do need the HART communication version, because we need HART communication to drive the controller. And also, don't forget to download the DD library to control this one. Otherwise, if you only have the HART communication without the DD library, you cannot control it. Okay. So this is the manual. We have online overview, setup, and the device diagnostics. So normally we only need to run the online one, because online contains everything. So we have configure, service tools, and also the overview. So configure, we have a guided setup, detailed setup, or the categories. So the guided setup is like a setup wizard. So this is pretty useful for the customer. The first time they need to set up the valve and the controller. If we want to do some like menu change for some already used valve and the controller, we need to go to the detail setup. So that's a menu setup. So we have a mode and protection, response control, alert setup, status, instrument, and valve, and the actuator. Okay, so one thing I want to mention is the mode and protection. Okay, so this controller has two modes, not in service and in service. Every time you want to do any calibration or the adjustment through this HART communicator app, you have to switch the controller from not in service to not in service. So under the not in service, you can do a lot of like calibration, adjustment, or change some settings. But under the not in service mode, if you change the analog output signal, the valve will not move, because controller right now is not in service mode. Okay, so it will not change the pressure supply to the valve itself. So there's no movement. So every time you change any settings, don't forget to change instrument mode back to the in service right here. Okay. So let me show you something that I tested. So go back to the configure detail setup. Mode and protection. So instrument mode is something I just introduced that we can switch between not in service and in service. Control mode is to control is to change the control signal from between analog 40 to 20 milliamp and the digital signal. So as you can see right now, because the controller right now is in service mode, so we cannot change it. So if we do want to change it, we need to go back to the instrument mode and change to in service, not in service, sorry, not in service. and then control mode. Now we can change analog, digital, and test. Okay. Yeah. So right now, the valve is under the not in service mode, right? So if we change the milliamp, you see there's no movement on the valve. So because right now the controller is under the not in service mode. Okay. And restart control mode, we can select the resume last or analog or digital. Okay. So that means the control mode, we need to after the rebooting of the controller, the controller should receive analog or digital or resume the last setting. Okay. Yeah. So the alert setup, status, instrument, and valve and actuator. I actually didn't try a lot. Okay. Detailed setup. Response control is something I want to introduce. We have a turning. We have a travel and pressure control. We have the input characterization. We have the customer characterization table, and we have dynamic response. So the most part I use is the travel and pressure control. We have the travel and pressure select. We can select travel control or pressure control. Cuts off and the limits. This is the very important thing for the customer. They may need to set up. So cut off or the travel, you can only enable one. So the cutoff, that means, for example, normally 4 milliamp, that means 0% close. And the 20 milliamp, that means 100% open. So when we set a cutoff high, okay, so cutoff high, we can see that's a number in percentage, and low is a number in percentage. So, for example, if we set the cutoff high as 99, so that means if we send the milliamp signal higher than the 99% of the 4 to 20 milliamp range, for example, we send 19.8 or something, okay, the valve will not go to like 99% of the range. It will strictly fully open. Okay, so cutoff low, same thing. For example, if we set the cutoff low as 10%, that means normally we should have like 5 milliamp, and then that should be corresponding to like, for example, 5% opening, something like that. But if we set cutoff low, like 10%, that means if the output signal is lower than 10% of the range, the valve will be fully closed. Okay. Not sure if you can understand that. Okay. So that means, for example, this is the range. Okay. So this is the range, and this is the signal output ratio. Okay. And then normally we have the valve close, and then smoothly to the fully closed, right? But if we do have a cutoff, for example, if we move here and activate the cutoff, it will strictly close, no matter the output in this range. It will just reach the cutoff high or low limit. It will just fully close or fully open, something like that. Trouble limit, that means the moving part can only move from the beginning is 0, 100%. If we set up like low as 20 and high as 80, so that means we just squeeze the movement range of the valve from 0 to 100 to 20 to 80. Okay, something like that. So the other thing is the number right here. The high limits 125%. That means this active. Okay, and the low, if you see minus 25, that means this active. So the interesting thing is if you set the cutoff, and then the trouble limit will automatically go to the 125 and the minus 25. So that means that you can only use cutoff, or you can only use the limit trouble. You can only use one of them. If you use the cutoff, the trouble limit will be disabled. If you use the trouble limit, then cutoff that will be disabled. So the disable, how you can see this disable? If you see the high is 125, that means disable. Low is minus 25, is disabled. If you set the low limit, for example, to minus 23, that means that is enabled. For example, right now we see 105 and minus 5, 125 and minus 25. So for example, we change it. For example, we leave the 125, and then to the low limit, we change to minus 23. And then you can see that 105 is still 105 because this is 125. This one is inactive, so this one is active. This one would change to minus 23. So this one automatically changed from minus 5 to minus 25. That means cutoff low is disactive and trouble limit low is active. Okay. So this is the cutoff and the limit. So let me show you. Let's see if we sorry. So let me show you how does it work, trouble limit. High, we say like 125, no problem. For the low, let's see, 10%. So that means the movement of the valve can only go to 10% of the opening. It cannot fully stop, fully close, because we have the trouble limit low. And then, in order to show you, so we set up the cutoff high to 90%. That means once the output, the control signal is higher than 90% of the range, then it will fully open. Say 90. And the cutoff low, because we want to show the trouble limit low, so we leave as a minus 25. Okay, now we change to in-series. Then you can see the difference. Okay, so let's go back to the category. Okay, so right now it's opening, right? So if we go to 8, it's 25%, no problem. If we go to like 4, if we don't have the trouble limit low, it should go to 0. But right now, because we set the trouble limit low, we have 10%. Okay, because we set the trouble limit low as 10%. And go higher, 21 is almost 100% open. Okay, so for example, right now, we go with 18. It will close a little bit. 19. It will just directly to the fully open. Fully open. Close a little bit. Okay, so this is because we have the cutoff high setting. Okay. To calibrate this one, we need to go to the communicator. Okay, online, configure, calibrate. So we can calibrate the trouble right here, the sensor right here, and relay. Relay is actually the switch inside of the controller to switch the output of the pressure between output A and B or both. So this is what they call the relay. And then we have the restore factory setting. Okay. So for the trouble, we can just do the auto calibration or the manual calibration. So auto calibration, that'll be, you will see everything fully automatic. So the movement will be from 0% to 100% and fully set up. A manual, that'll be like the first point, that'll be the middle of the entire trouble, and then 0, the bottom, and then 100, and then 5%, and 95%. And this is the manual calibration. Yeah, one thing I do want to introduce is a reason why I spend like 3 days to take this video. It's just because the mechanical part of this Fisher GX valve is not really good. So this one cannot fully close or fully open. So as you can see, one second. Let me turn off the cutoff and the trouble limit. So simply saying that is normally if we have a 4 milliamp analog output, we should see the valve is fully closed. And then if we output like 20 milliamp, we should see this one fully open. But this valve can only give me like 0.2% open at the 4 milliamp, which means it cannot fully close. And then for the 20 milliamp, it will give me like a 99.8% or something. And if I go with the 3.8 milliamp output, which means over close, it's stuck at the 0.2. And then if I output like 21 milliamp, that means over open, it's still giving me 99.8. And we tried everything under the menu, try to fix it, but failed. Just because this is definitely a used device. So we don't know if there's something like contamination inside of it, so which stop the movement or stop the movement of the what is called actuator. So it cannot fully open or stop. Or the inside of the protocol is an old protocol. I don't know. So this is the reason why we spent like 3 days trying to fix it, because we want to show you everything. We want to show you everything perfectly, something like that. So yeah. So anyway, so yeah, this is the how we can use the 227 HART communication to, you know, test and control the valve positioner. Okay. Yeah, I think that's it. If you have any questions, just send me an email. All right. Thank you guys. Have a great weekend. Bye-bye.